Hello everyone, the topic I want to introduce today is a biological Indian Ocean Dipole event in 2019. Indian Ocean Dipole (IOD) is a continuous difference in sea surface temperature between the eastern and western equator Indian Ocean. It usually starts at May in June, reaches its peak in August and October, and fall off when the monsoon comes in the end of spring. And we can use the DMI index as a measure of IOD. Australian scientists call DMI value above or below the monthly average 0.4 degrees Celsius as positive IOD and negative IOD respectively. During the positive IOD, the eastern part of the Indian Ocean, like Sumatra, will have strong southeast wind and upwelling. It leads to cold SST anomalies and shallower thermocline. A warm SST anomaly appeared in the western Indian Ocean, and the thermocline becomes deeper. On the contrary, during the period of negative IOD, the westerly wind strengthens along the equator, causing more water to concentrate near Australia. The east is warmer than normal, and the west is colder than normal. This picture is neutral IOD base. Whether it is a positive IOD or negative IOD event, it will have an impact on the equatorial Indian Ocean, such as precipitation in East Africa and Sri Lanka, or coral bleaching, forest fires, and so on. We want to propose and identify and quantify biological IOD and further understand and solve the dynamic of driving nitrates as well as mechanism of abnormal biological activities. In this study, we observe and analyze chlorophyll A in the east and west IOD region through Zoomi National Polar Octane Partnership. SMPP is a satellite that carries detector to monitor the Earth's environment and climate. VIIRS, used by this research, is also the largest instrument on SMPP. SMPP can collect visible light and infrared radiation images from land, ocean, atmosphere, and ice layer to observe fire, vegetation, ocean color, and sea temperature. Combined with the data from the NOAA Physical Science Laboratory, such as wide field, vertical velocity of water, etc., to understand the mechanism of abnormal biological activities. All data comparisons are monthly averages from 2012 to 2019. Including chlorophyll A, SST data, DMI data, and the climatological chlorophyll A data are seasonal averages. We can see climatological chlorophyll A data in the latest figure. Combined with the monthly average, in the SST in October, was lower than 3 degrees Celsius in the coastal area of Sumatra, as shown in Figure C. In other areas along the eastern shore, it has dropped between -1 to -3 degrees. However, in the western Indian Ocean, it is 1 to 2 degrees higher than the climate value. The DMI time series also shows that the IOD in the fall and winter of 2019 is the strongest event in the past 20 years. Next, let me take a look at the change of chlorophyll A in the East IOD area. Due to the proliferation of phytoplankton, the concentration of chlorophyll A in the East IOD area increased significantly. In the coastal area of Sumatra, chlorophyll A reached 3 to 4 mg per cubic meter in October 2019. And the typical value of the climate along the western coast of Sumatra in the same month was less than 1 mg per cubic meter. Chlorophyll A comparison chart of climatology in October and October 2019, as shown in Figure C, clearly shows that there was a large number of phytoplankton reproduction in East IOD area in October 2019, and the ratio reached 4 to 5. In the area of East Sumatra and Java, and the average chlorophyll A is similar to climatology. From Figure D, we can note that the abnormal growth of phytoplankton in fall of 2019. We also observe chlorophyll A in the West IOD region. Contrary to East IOD region, in the coral and offshore area, and chlorophyll A in October 2019 was markedly lower than the climatological data in the same month. From Figure C, it can be found that in some nearshore area of this IOD zone, chlorophyll A decreased by more than 0.3 mg per cubic meter. We can also clearly see the abnormal biological activity of the IOD event in 2019. From the time series in Figure D, the seasonal change in this area are manifest. The highest value usually appear in July and August. About 0.26 mg per cubic meter. As an ocean atmosphere event, the generation of IOD is closely related to the atmosphere. From this data, we know that the strengthening of wind in the eastern equatorial Indian Ocean lead to an increase in the upwelling in the eastern IOD region. In Figure A, the upwelling can be about 3 meters per day. And the average in Figure B is usually less than 1 meter. Even if the data of October is compared with the October average, we can still observe that it's still stronger than its average monthly vertical velocity. On the contrary, in the IOD area in the southwest, September 2019 showed downwelling that was more obvious than the average. It is also occurred in October, but it was not so obvious compared to September. It means that in 2019, wind-driven and enhanced upwelling will bring high nutritious seawater to sea surface, causing phytoplankton to proliferate in eastern part of IOD. However, in the western IOD region, the downwelling in September and October 2019 indicate that during the positive IOD period, the thermocline in the region will be deeper, which may lead to a lack of substance needed for phytoplankton growth, resulting in lower chlorophyll A concentration. It is worth to mention that during the negative IOD event in 2016, the DMI value dropped to negative 0.5 degrees Celsius. Figure D shows the concentration of chlorophyll A in the eastern part of IOD. That was significantly lower than the climate value of chlorophyll A, which shows that biological inhibition activity occurred in this area during a negative IOD event. Contrary to the positive IOD period in 2019, as shown in Figure D, it can be seen that the chlorophyll A concentration in the western IOD region increased slightly in 2016. Compare the vertical velocity of seawater in 2016 and 2019. The dynamic obstacle to land in 2019 did appear in 2016, such as weakening of upwelling in the east IOD area. In this study, we use SMPP and physical data to know that during the positive IOD event in 2019, because the strong wind and lower coast of equatorial eastern Indian Ocean, upwelling becomes stronger and the sinking of water in the equatorial western Indian Ocean. Due to a concentration of surface water, the east and west change have caused clearly biological change in the equatorial Indian Ocean. It shows that the concentration of chlorophyll A in eastern IOD and in area increased from the climate value 0.3 to 0.5 milligram per cubic meter in October of that year. Compared with the climate value in the western IOD area, the chlorophyll A concentration in the western IOD area has dropped by more than 30%. Any question?
Okay, so
can you explain the sea surface temperature with the east and west different?
repeat his question.
Hello?
Yeah.
Explain sea surface temperature between eastern and western IOD regions in 2019? Okay. Okay, in positive IOD regions, the eastern part of Indian Ocean, because the wind, it will bring ocean in bottom to the surface. So the SST will be colder than the normal. And because wind, there are concentration in western part of Indian Ocean. It will cause downwelling. So it will cause SST is higher than the normal value.
Can you tell me how the SMPP works again?
Pardon? SMPP.
How SMPP works?
Repeat his question.
How SMPPs work? It is a satellite and it can get the visible light and infrared radiation images from land, ocean, atmosphere. So it's based on the visible light and infrared radiation images.
What is the impact of the negative IoT to the local climate or weather?
Okay. And what in the negative IoT, positive IoT, right? And how positive IoT can influence the local climate?
Positive or negative?
Or negative? Contrary to positive IoT, negative IoT the westerly wind strengthens along the equator. So there is a concentrate near Australia. So there is a low pressure. It causes rain in this part and high pressure in this part. It will be waterless or hot in this area.
And why is the chlorophyll A different between west and east?
Why chlorophyll
A is different between east and west?
Because the upwelling, in the upwelling area, it can rise the chlorophyll A value. Because the upwelling, because chlorophyll A usually at the depth of 50 meters in Indonesia's area. So when upwelling becomes stronger, chlorophyll A will more than the normal value. And if downwelling more stronger, the chlorophyll A was is less than strong, is less than normal.
If the wind more strong or less will change the positive more positive or negative more to negative.
Pardon?
Repeat again.
You say the wind will change the SST more. How to say?
Isotherm.
Will the wind more strong or less will change the therm in the west or east?
I think you have to change your question to an easier one. Okay. So first of all, let's talk about the good part of this talk. So first of all, it's basically a physical oceanography topic, and that's a relatively difficult topic. And I think he did a good job. For example, at the beginning, he introduced where's the figure like this one. So he introduced the concept of IOD with these cartoons. That's generally easier for the public to understand what is going on. However, my feeling is this figure is too small. When I was standing at the back, I can barely see like this. Oh, now I can read it. It's downwelling, it's upwelling. But when I was standing there, I couldn't see it at all. So you really have to enlarge this figure. And then the next good thing is that's too much animation. So he had a very clear purpose slide. So I know very well what this study was about. This is really nice. And another good thing of his presentation is he always have these markers like to point out, for example, like he used animation and he point this color to the value here, so you know what this is about. And also, I also like his conclusion, although I was a little bit distracted because he was already over time. But I think this is a very, very nice conclusion. So you see these simple, short keywords, and there's a flow of logic here. So I think the conclusion slide is really nicely done. But there's, of course, things to be improved. So, for example, the major drawback of his presentation is I saw that he was really looking at his pad most of the time without really looking at you. So there's no interaction with the audience, and he didn't use the pointer well. So although he had markers on his slide, but still sometimes it's difficult to figure out what he was really talking about, especially when he has multiple panels. For example, he often have these kind of figures, and this kind of figure had a lot of information, and he just talk and talk. Sometimes with the markers on the slides, but still, the best thing is always to use your pointer to guide the audience where you are talking about. And then another key drawback is he had this kind of figures, and the best way to present this is let's go to this slide. For example, it's better that you talk about the x-axis, y-axis first, the first time you show this kind of figures. Because when you show this figure, you were starting to talk about what's positive, what's negative. But it's good to introduce this figure a little bit. Yeah. And considering you are slightly over time, I think you can skip the negative and the neutral phase. It's not used in this talk. And sometimes, from time to time, you have to check yourself. For example, in my opinion, this is unnecessary space here, space here, space here. These are unnecessary, and you can really enlarge your font to, let's see how much it is. It's only 24, so you can make it much, much larger, for example, 32 point. And the same for this, and this is ugly. Yeah. And then here, it has, if I were you, I would skip this ABCD, because it's a little bit time consuming for the audience, have to look at the figure and have to read the text. I will simply print the keywords directly next to the figure. And I will skip these lengthy sentences. Yeah, it's especially like this one and this one. Oh, I don't spend time reading them, that's too long. And then from time to time you have this term, climatological. You have to explain that, because this term is a little bit like the reference line. So you have to spend time explaining that. All right? And then, again, if you have multiple figures, panels like this, a good strategy is always you show one first, and then you show the rest in one figure. And you use, for example, the very first one to explain the scale bar here. All right. And then following one of the questions from the audience, one student was asking something related to chlorophyll A. So you have to, at some point, maybe at the beginning, in introduction, you have to explain what's the relationship or what is the expectation regarding the relationship between chlorophyll A and IOD. It's a little bit like your hypothesis. Okay, but overall, I think he gave a very fluent talk. I hope next time you can really looking at the audience. I think you can do that. Okay, let's thank Liang.